Okay, so in order to do this one here, we've got to first find the formula weight of these compounds. So what I need to do is look at the periodic table and see what is the mass of 1 mole of sodium, 1 mole of oxygen, and 1 mole of hydrogen. Add those together and I'll get a formula mass of 40 grams for NaOH. Then I say what is the mass of 1 mole of iron plus 6 moles of bromine. And when I do that, I come up with a whopping 536 grams. 536 grams for FeBr6. Now for aluminum nitrate, I take 1 mole of aluminum plus 3 moles of nitrogen plus, careful here, 3 times 3, 9 moles of oxygen. Add all of those together, and I come up with 213 grams. And then I do the last one here. It's 1 mole of magnesium plus 2 moles of oxygen plus 2 moles of hydrogen. Add all that up, and I get 58 grams. So now that I know these formula masses, I can proceed with the following. Okay, so how do you do this first one? How many moles? So I'm looking for moles here. And like always, you start off with the measurement you given. Now I'm going to tell you, don't you start with big M. This is a conversion factor. This is really saying 3 moles equals 1 liter. So what I just remember is don't you start with big M. So you're going to start with whatever else you have. What you have is 450 milliliters. I don't want milliliters. I'm going to put them in the basement. I'm going to turn those into liters. 1 liter is 1,000 milliliters. I don't want liters, so I'm going to put liters in the basement. And here's when we're able to say 1 liter of this solution contains 3 moles of solute. In this case, 3 moles of sodium hydroxide. And I'm looking for how many moles, so that's all I have to do. I don't have to do any more than that. I'll just say equals, and I'll get, I'll say 450 times 3 divided by 1,000. And what that gives me is 1.35 moles. Okay, don't you start with big M. That means you start with 250 milliliters, and in this case we're trying to get to grams. So I'm going to start with 250 milliliters, and I don't want milliliters, so I'm going to put them in the basement. That means I'm going to put liters up above. 1 liter equals 1,000 milliliters. And I don't want liters, so I put them down below. And here's where I can say 7 moles is the equivalent of 1 liter. So in 1 liter, there are 7 moles. That's what big M is telling me in this case. But this time, I don't want moles, I want grams, so I had to put moles in the basement. So I multiply, and I put moles in the basement. In this case, I say 1 mole of sodium hydroxide. Sodium hydroxide has a formula mass of 40 grams. So I put 40 grams up above. And I'm going to say 250 times 1 divided by 1,000 times 7 divided by 1 times 40 divided by 1. And that's going to give me 70 grams of sodium hydroxide. Let's try the next one then. Number 4. Okay. Again, I'm looking for grams this time of iron 6 bromide. So, don't you start with big M. Start with the other thing. 500 milliliters. Which I don't want, so I put them in the basement. And guess what? I'm turning 1,000 milliliters into 1 liter once again. I don't want liters, so I put them in the basement. Big M is telling me there are 3.5 moles of FeBr6 in every liter. So 1 liter equals 3.5 moles. I don't want moles, so I put moles in the basement. 1 mole of FeBr6 equals, remember that whopping 536. 536 grams. And so what that's going to give me then is 500 times 1 divided by 1,000 times 3.5 divided by 1 times 536 divided by 1 and that's going to equal 938 grams. 938 grams. Ooh, look at this next one. Be super careful here. How many bromide ions are there in this many milliliters of this molarity of this compound? So I'm going to have to break this compound up. So there's going to be an extra step here, but that's okay. You know what you're doing, you're going to do fine. So what do I start with in this case? I have to start with the volume measurement of 11 milliliters, which I don't want, so I put them in the basement. 1,000 milliliters equals 1 liter. I don't want liters, I put them in the basement. 1 liter in this case equals 0.033 moles. 0.033 moles. And I don't want moles, so I put them in the basement. Now watch this. I'm going to say in 1 mole of FeBr6, there are 6 moles of Br. And now that I've got Br, I want to find out how many ions, so I have to get rid of moles, so I'm going to put moles down below. I say 1 mole of bromide ions equals 6.02 times 10 to the 23rd ions. And that's going to give me 1.3 times 10 to the 21 ions. And sorry, I don't have room to write ions. Alright, what's next here? Alright, if you want to make a 0.1 molar, don't you start with big M. So I'm going to start with the other number I have, 1,000 milliliters. Here's 1,000 milliliters, and I don't want them, so I'm going to put them down below. Starting to see a pattern here. 1,000 milliliters equals 1 liter. And I don't want liters, I'm looking for grams. So I'm going to put liters down below. And here's what I'm going to say 1 liter equals 0.1 mole. See where I got that? That's what big M tells me. It says that there are 0.1 moles in 1 liter of solution. Now, I don't want moles, so I'm going to multiply and I'm going to put moles down below. And now what I have to do is I'm going to turn moles into grams. But that means I got to look up MgOH. Let's see what I got here. So let's go up to the top. MgOH, there it is. That's 58 grams. So we're going to come here and we're going to put 58 grams up above equals 1 mole down below. And I believe I just have to then multiply that through. So I'm going to say 1,000 times 1 divided by 1,000, so that's 1, times 0.1 divided by 1, times 58 divided by 1. You know, I can do that one in my head. That's going to be 5.8 grams. Ooh, we're going to switch things up on this one though. Look at this. Okay, now I want to know how many milliliters. So I'm going to start off with moles and turn moles into milliliters. And you know what I'm not going to start with? I'm not going to start with big M. So I'm going to start instead with this, the other thing I have, which is 0.5 moles, which I don't want, and I'll put down below. And you know what I could turn moles into? I'll tell you what I could turn moles into. I could turn moles into liters. That's what big M is telling me. It's saying that there are 7 moles of this chemical in every 1 liter of solution. That's what this is telling me. It's a conversion factor between moles and liters. So now that I got liters, I don't want liters, so I'm going to put liters down below. 1 liter, as always, is equal to 1,000 milliliters. I should put the ml there. There you go. Alright, and when I multiply that through, I'm going to say 0.5 times 1 divided by 7 times 1,000 divided by 1, and that gives me 71.4 milliliters. Okay. Now let's see what the next one says. I'm not going to start with big M. I'm looking for milliliters again. This time I start off with 50 grams of solute, and it's MgOH again. Let's just refresh my memory. MgOH has a formula weight of 58. So let's just try this then. I'm going to start off with 50 grams. It's a terrible 50 grams. I don't want grams. I'm going to put them in the basement. I can turn grams into moles. That's the only thing I can turn to. 1 mole of this substance right here has a formula weight of 58. So I'll put 58 here. 58 grams equals 1 mole of MgOH2. I don't want moles, so I have to put them in the basement. No choice there. You know what I can turn moles into? I can turn moles into liters. And here's how I'll do it. I know that 1 liter of this solution contains 4 moles. Wait, what did I just do? Let me erase that. That was silly. Okay, whoops. Okay, 4 moles. Alright, and then let's go back here. I didn't want liters, I wanted milliliters, so I'm going to turn my liters into milliliters like this. I'll say in 1 liter there are 1,000 milliliters. And then I'm going to say 50 times 1 divided by 58 times 1 divided by 4 times 1,000 divided by 1 equals, and when I do that I'm going to come up with 215.5 milliliters. And you know what? I'm not doing a very good job with my significant figures. Really, I should just call it 200 milliliters. But you know what? We can't all be perfect now, can we? Alright, we just got a few left here. Oh no, how many nitrate ions? Ooh, that means I had to break apart this compound. So I want to know how many nitrate ions there are in 255 milliliters. So I have to start with 255 milliliters. I don't want milliliters, so I'm going to put them in the basement. I'm going to say 1,000 milliliters equals 1 liter. I don't want liters, so I'm going to put it in the basement. Are you getting tired of me saying that? I don't care. I'm going to say it anyway. 1 liter of this solution contains 4 moles. That's what this tells me. I don't want moles of... now, I should point out here, at this point, what I have is I have moles of AlNO3. And that's not what I want. So I'm going to multiply by a fraction. And I'm going to say in 1 mole of AlNO3, there are 3 moles of NO3 ions. You see how I did that? I looked here, it said in 1 mole of this, there are 3 moles of nitrate ions. And now I want to know how many ions, so I need to turn moles into particles. So I'm going to multiply and say 1 mole equals 6.02, where's my point go, times 10 to the 23rd. And I'm going to multiply that all through. Let's see if I can fit it in here somehow. And what that's going to give me, by golly, is 1.84 times 10 to the 24th ions. And I did that, as you can guess, by saying, let's see, what is that? What I start with here? I had 255 milliliters times 1 divided by 1,000 times 4 divided by 1 times 3 divided by 1 times 6.02 to the 23rd divided by 1 equals. Alright, well, let's try. There's just a couple more to do and we'll be done with our homework. Let's see here. Number 10. Let's see. Number 10. We want to know how many milliliters of this. Okay, so in this case, I have 2 big M's. Now take a look here. I've got a high concentration of big M's and a low concentration of big M's. And the way I like to think of it is put what you want on top and what you've got down below. So this is a little bit different. So in this case, what you're going to say is I have 250 milliliters. And so what I'm going to say is times what I've got down below, which is 12m, and what I want up above, which is 2m. So notice, in a dilution, the big number is down below and the little number is up above. And that's important because this, the number of milliliters you end up with has to be less than what you started with. So this fraction has to be less than 1. What you've got divided by what you want to end up with. And so if I say 250 times 2 is 500 divided by 12, what I end up getting is, what I get is, when I say 250 times 2 divided by 12, I get 41.7 milliliters. And there are other ways of coming up with this. This is just the way I like to do it. So let's try the next one. It's going to be the same way. So in this case, notice I have, I say how many milliliters of the high concentration do you need in order to make this many milliliters of the low concentration. So as always, you never start with big M. You start, in this case, with milliliters, 100 milliliters, and I multiply by a fraction that has what you've got down below, 6.2, the large concentration, and what you want up above. I want to end up with 1.5 moles per liter. And so you notice the big M's cancel out in this case. See, big M cancels out big M, leaving me with milliliters. So in this case, I'm just going to say 100 times 1.5, that's 150, divided by 6.2, and that's going to give me 24.2 milliliters. And what that means is, if I took 24.2 milliliters of this concentration and then added water until I got to 100 milliliters, it would become less concentrated. In fact, as soon as I got to 100 milliliters, I would have ended up at this exact concentration. It's pretty cool. Alright, hope you enjoyed that as much as I did. Almost done with this unit. I hope you're studying for your test. Your test is on Friday, don't forget.